In this proof-heavy chapter, the ones from this section end up being the longest. I hope you got your practice in with the easier proofs that led up to this section. Before, we have had situations like this, where there were lots of triangles involved in the picture. How many pairs of congruent triangles are there? There are 3 pairs. Students often forget about that last large green pair. When encountering pictures like this previously, I said that it is often helpful to highlight the triangles you are targeting with either colored pencils or highlighters in order to isolate the pair that you want to work with. Students often find that very helpful, especially if you're having any trouble at all visualizing what is happening. In this section, we will be dealing with overlapping triangles, like these here. Highlighting the triangles that you're working with is still a useful skill. Let's say I want to highlight triangle ABC and triangle CDA here. Colored pencils and highlighters can help. Once you have highlighted the triangles that we're working with, another thing students like to do is to redraw the triangles to highlight what they need to. Some of you will find this more useful. Just like the doubler colored line from before showed you which side was reflexive, the fact that we have 2 line segment ACs here should also show you which sides are in common and would make for a good reflexive step. Highlighting will help many of you figure out which triangles we are looking at, but some of you are going to think that you're a geometry god and don't need no stinking highlighting. That's fine. The choice is yours. Somehow, some way, you need to be able to deal with these overlapping triangles. Back to this picture. As I said earlier, there are 3 pairs of congruent triangles here, but we want to focus in on these 2 pairs, the small pair on top and the big triangle. One of the hardest proofs in geometry is when you have to prove one pair of triangles congruent and then use some part or parts of that first pair of triangles to prove a second pair of triangles congruent. For example, let's say that we are in the middle of a proof and we have proven this pair of triangles congruent. We will want to use some part or parts of these blue triangles to help us prove these green triangles are congruent. To pull that off, we usually need to identify the common parts involved, parts that are the same for both pairs of triangles. So, what do the blue triangles have in common with the green triangles? There are 6 things to check. 3 pairs of line segments and 3 pairs of angles. Let's take them one at a time. First, we have this segment here, but that line segment isn't one of the sides of the green triangle, so that one's out. Then we have this piece. This is one full side of the blue triangle. However, it is only a piece of one of the sides of the green triangle. If they share a side, they must share the whole side. Strike 2. 4 to go. Now we have our last side to check. Fortunately, this time we have a match. This side is a common part for both triangles. Those common parts are very useful for proofs. Now we need to look at the angles. Here is an angle for the blue one, but no match in the green one. That angle doesn't exist for the green one at all. This is going to be similar to the second side we looked at. Here is one of the other angles for the blue triangle. But for the green triangle, it's only part of the whole angle. It isn't the whole thing, so that doesn't count. This is no good. Finally, we have this final angle to check, and this time we have a match. This angle is common to both triangles. So of the 6 possibilities, we had 1 common line segment and 1 common angle. I have said these common parts are useful in a proof, so let's see an example of how. Here's our proof. The picture should immediately scream out to you that we have a bunch of overlapping triangles. In fact, hopefully you could see that we once again have 3 pairs of potentially congruent triangles here. You need to work hard to make sure you don't miss one pair. Students often forget the big green ones. Now, one of the most common things to do with a proof when you're confronted with so many possible triangles is you prove one set of triangles congruent, then use some of those common parts from that triangle to help you prove a second pair of triangles congruent. And that is certainly what we will be doing here. But with so many possible triangles, students often have trouble knowing where to start and go. So I present you with my logic, an insight into my brain. Don't get scared. First, our given information is clearly geared towards these triangles. That's clearly where we should begin. The given is just a big, huge, flashing sign that this is where we begin. Now, what about the final step? Well, we eventually have to prove that line segment TU is congruent to line segment TW. What's unfortunate is that those line segments are part of both of the other pairs of triangles. That doesn't help us figure out where to go. So now what? Which direction should I go? Well, in truth, you can go either way. Either the blue triangles or green triangles will work. However, one is quite a bit easier than the other. The thing you should be looking for is the common parts. You need to ask yourself which pair of triangles has more common parts. The red and blue triangles have 1 line segment in common, but the green and red ones have 1 line segment and 1 angle in common. Last I checked, 2 is greater than 1. So that's our game plan. We will start by proving the red triangles congruent, and then move on to proving the green triangles congruent. Hopefully, it will be helpful for you to see my train of thought. Let's see what the proof actually looks like. First, get our free points. Put in the given. We should start with trying to prove these red triangles congruent. We have 2 angles already. They also share a common side, so that's what we need next. We now have enough to prove the red triangles are congruent. Now that we have proven the red triangle is congruent, it's time to shift gears and focus in on the green triangles. We need to use the common parts from the red triangles. The common angles, angle 3 and angle 4, are already done, but we need to add in this common part to our proof. For these common parts, the reason we will use is CPCTC, that step that always seems to come up right after proving triangles congruent. As it stands now, we have two parts of the green triangle done, but they also have a common side, so we can use the reflexive property to add that in. We now have enough to prove our triangles congruent. And now we can do another CPCTC step after the triangles are congruent for us to get to our goal. That's how you identify common parts and how they will be useful when you do some of these more complex proofs.